Okay, well, as we saw, and figured fairly quickly, that dq1 dt is the rate at which q1 is coming in minus the rate at which q1 is coming out, right? Because this is the rate at which q1 is changing, okay? q1 being the quantity of the solute in this tank. So it's this, okay? Now, what's the rate at which solute is coming in? Well, it's coming in from over here. And to get the rate at which solute is coming in, you take the rate at which the solution is coming in times the concentration, right? So we can write a little note over here because we want to be sure we understand this. This is very important. The rate at which solute is coming in, so we could say rate at which solute comes in, right, is the rate at which volume enters or comes in times the amount of solute per unit of volume. Okay? Now, of course, this is something you already understand from what's been done with single tank, okay? With stuff coming in and going out. Okay, so there's nothing really new about this concept, but it's been a while since we talked about it. Since you're about to be tested over it, though, it's a good idea to refresh yourself, okay? And what's that? Well, R is the rate at which volume comes in, and the amount of solute per unit of volume is the concentration, right? So we can summarize this as the rate of volume, the rate at which volume comes in times the concentration that's coming in, minus the rate at which volume is going out minus the concentration going out. And then that's easy to write. The concentration coming in is coming from here. It's Q2 over V2, right? And the concentration going out of, the rate at which Q1 is changing, of course, is the rate at which concentration from here is being pumped out. So it's rate times concentration, okay? Same rate in both cases. That can get more complicated, and it does pretty quickly. But now we can easily write the equation, and you got it here. Okay, once we got this, it was pretty clear what this was going to be. And it's just, the rate at which stuff is coming in to here, which is the rate at which it's going out here, right? So you're just going to kind of reverse these two, and that's pretty clear. Okay? Okay, well. I'm just debating about whether I want to do a numerical example or symbolic. I'm going to go ahead and do symbolic. So we have two equations. Okay? Now I'm going to write them a little more. And it's, I'm looking at this. I should be looking at this. So here's this equation. Just rearrange it a little bit, right? Okay? Now I want to just change this, so my next step is obvious. I want my Q1 and Q2 to be in the same order. Okay? So I'm just going to call this V1 and Q1, but I'm going to put a negative in front of it. And I didn't even put a subscript in this, that'll be easy to change. Q2, okay? So it's still the same as this equation, I've just reversed 2 terms, okay? Okay, well, I'm going to write this in a form you're going to love because it's going to cause you to review stuff you haven't thought about for a year. Okay? This is nothing but
yeah, for normality. I thought you did. Okay. Oh, and these other two. Okay, these other two.
should have left myself room. I really do kind of want to write this on the left. So.
The next thing is you subtract.
Do you agree we can write the equation like this? I'll let you ponder that for a minute.